Next, we have OSI model. So first thing, why we have this model? Or what is OSI model, first of all? So in the basic introduction, when we were discussing network components, I gave you a small introduction to the models. That what are these models? These are nothing but set of documents only. All of these models, as of now, we are having three models. One is the TCP/IP original model, or also called as a DoD model. Then we have your OSI model. Then we have your TCP/IP updated model. Okay, these are the three models. Based on the time duration, they were designed, like this was designed around 1960s or 70s. Then in the 1984, your OSI model came up, and in the year 2000s, your TCP/IP updated model came up. Okay. Now your early internet that was designed on the TCP/IP original model. Okay. So all of these three models, whatever these models are, these are nothing but set of documents only. And in these documents, what is there? Some protocols have been defined. Okay. And what are protocols? Set of rules. And what these rules define? That how your network devices or the communication is going to take place, or how the network devices are going to function. Okay. So to basically understand how the network communication is taking place, when you're sending a hi message from your phone and it reaches your friend's phone, so what is the backend process? Okay, to understand that process, we have these models. So if you understand the process and if there is some error, that means it will help you troubleshoot also. Okay, you can troubleshoot that at which point, at which layer the error is, and according to that, you can eliminate the error. Okay. So these models, nothing but set of documents which are having the protocols defined, and these protocols define what? That how your network devices are going to function. Okay. But why do we require these OSI model? Why specifically OSI model we are studying as of now? Okay. Or why do we require any of these models? Because see, your early internet was designed on the DoD model, Department of Defense model. And in the your first networks, when they were designed, how they were designed, there was a big wire. Okay, at the end of the wire there were terminators. Okay, and then you used to take PC, and from the PC you used to connect the cable and connect here. Take a cable, connect here. Take a cable, connect here. Okay, they were using the coaxial cable for the communication purpose. Have you seen a coaxial cable? Yes. How many? Have you seen or not? No? Okay. In our homes, we are having the dish TV DTH connections. Have you seen that black cable coming from the satellite to your TV or the set-top box? Black cable that is having one single wire in the center. That is the coaxial cable. And that cable was being used for the network communication. Like just cutting down the cable from one place and connecting the wire. Cutting down, connecting, cutting down, connecting. Like this, the internet communication was happening. Now, again, this kind of communication was not really helpful. Why? See, at a time, if one PC is sending some data, that means in a wire, how the data will flow? Electric signal. In wires, what is going to flow? Electric signal, right? So if at a time one PC is sending, first of all, that will go to everyone. Second thing, at the same point of time, if someone else is also sending, that means it's like taking two wires and then combining them. What will happen? Short circuit, right? Means collision will happen. And when collision happens, no communication happens. Is that clear? So that was designed on these kind of scenarios. So what happened? Again, there was one more problem. What was the problem? Later on, they started using the devices like hubs, okay? And they were having the Ethernet cables also. But still, there was a problem. What was the problem? Let's say we have a company, Dell. Okay. So what Dell does? Dell manufactures your monitors, keyboards, okay? And your CPUs, all these things. So when Dell is manufacturing these products, okay, these devices, what Dell will do? Dell will also decide that how these are going to function. Means Dell will design their own set of protocols. And if you have some other company also, for example, let's say IBM. Okay, in earlier times, IBM computers were in use. So let's say IBM is there. So IBM were creating their own set of protocols. Okay, there was no standardization. So let's say at a certain point of time, you are see, with the companies, that was not a problem. Why? Because the companies were in profit. If someone is trying to buy an IBM monitor, the IBM monitor will work only with IBM CPU, IBM keyboard, IBM mouse. Okay, so means everything has to be purchased from a single vendor. Now, problem was not with the companies, but with the users. What was the problem? Let's say if you are setting up a business, if you are setting up a business, you need systems. So what will happen? Let's say at right now, you find IBM computers are good. Okay, so you designed your entire network on the basis of IBM. Now these computers, since they are all from the same vendor, they are going to communicate. No problem is there. Okay, but at a later point of time, you want to expand your business and you came to know Dell is the new company providing good service and cheaper options. So at a later point of time, you buy Dell. Okay, now you set up Dell systems. They will communicate with each other. But when it comes to intercommunication, they will not communicate. Why? Because Dell is having their own protocols. IBM is having their own protocols. Means they have different rules, how they are going to communicate. So they were not communicating. This was the issue. Means multi-vendor communication was not possible. Okay. Then even if somehow your network admins did something and configured them to communicate with each other somehow, okay, then the complexity of network became so high that for troubleshooting purpose, this is like a really hectic task. Okay. So for multi-vendor communication, because see, the users were fixed with a vendor. If they want to use Dell, they will use all Dell. If they want to use IBM, they will use all IBM. But what happens right now? Right now, you can buy a Dell monitor, you can buy a Lenovo CPU, you can buy a Acer keyboard, you can buy a HP mouse, and still they communicate. Why? Because right now we have the standardization. We have standard set of protocols. Okay. So in the year 1984, the early internet wasn't really successful. So in the year 1984, the organization ISO came up. International Organization for Standardization came up and brought up the OSI model. OSI stands for Open System Interconnection. So how did the OSI model help? In the OSI model, they designed again what? Protocols. But this time, these protocols were standard protocols. And they invited all the vendors and manufacturers to use the OSI model to design their products. Now, each and every vendor started using the same set of protocols. So if every person is speaking the same language or using the same set of protocols, they will be able to communicate. You know, the early communication was like, okay, you have a Japanese person from Japan speaks Japanese, and you have a person from India speaking Hindi. Will they be able to communicate? No. What the Japanese person is saying, Indian will not understand, and what Indian is saying, Japanese will not understand. But what happened? At a later point of time, some organization came up and brought up a common language. And now they started understanding each other. And similar way, we have the OSI. That all the vendors started using the common set of protocols. So these devices start communicating with each other. And right now, that's why we have the multi-vendor communication possible. Okay. This is clear? Okay. Now your OSI model. So TCP/IP original model or DoD model wasn't really successful. So not much in use. Then we came up with the OSI model. Now, when the OSI model came up, what happened? There was a situation around the 1990s. Okay, around the 1990s, there was a situation. Why? Because some companies were already using the TCP/IP original model, and some companies were using the OSI model. Okay. So again, some conflict was there. So what happened later on? The OSI model, it was getting updated very slowly. It was getting updated very slowly, means new set of protocols were getting defined slowly. And the TCP IP model, this was getting updated faster. New set of protocols, new rules, everything was getting defined faster. Okay. So what happened? With the time, your OSI model just became obsolete, you can say. Okay. The vendors were not using it. Why? Because always all the vendors want that their systems should be sold, or they want to remain in profit. So they have to cooperate with the latest technologies. Latest technology means latest and new protocols. So they keep on using they shifted towards the TCP IP model. Okay. And the new TCP IP model came up as TCP IP updated model. Okay. So with the time, all the vendors shifted to TCP IP original model. So right now, all your devices, they are being used or manufactured on the TCP IP updated model. Your entire network communication is happening based on the TCP IP updated model. Okay. We are not using OSI model. We are not using TCP IP original model or the DoD model. We are right now only using TCP IP updated model. Okay. Then why we are studying OSI model? Because when your TCP IP updated model was designed, so whatever protocols have been defined already in the OSI model, the same protocols were not again defined in the TCP IP model. Okay. So how those protocols are working in the TCP IP model? So whenever it comes to the protocols that are already defined in the OSI model, okay. So what happened? For those particular protocols, your TCP IP model refers to the OSI model. Means, okay, this protocol, go to the OSI model. This protocol, go to the OSI model. New protocol, it's already here. Okay. So this way, your OSI model came to be known as OSI reference model. Your OSI reference model. So since your TCP IP updated model is based on the OSI model only, okay. So what happened? This is the basic understanding model. Because in your OSI model, we have total 7 layers. In case of TCP IP model, you have only 5 layers. Okay. So for basically understanding the network communication process, we'll go with the OSI model. What will be the difference? Let me show you the difference also. So what is OSI and why do we need it? That is clear for the standardization of the protocols. Okay. These are the all 3 models. So this is the TCP IP original model, was having only 4 layers. Okay. And sometimes the questions are asked about these layers. What is the name? Because the difference is there in these names. Okay. In the TCP IP original model, the data link layer, or sorry, the network layer was known as internet, and the data link layer was known as link layer. Okay. But then later on, what happened? The TCP IP updated model came up, and we have the OSI model and the TCP IP updated model. What is the difference here? The difference is just that here we have these 3 layers as separate layers, and here they have been combined into one single layer. Remember, we said software layers. These 3 layers, the top 3 layers, we call them as a software layer. Why? Because one application was doing all the tasks of these 3 layers. Okay. So here, instead of saying 3 layers in the TCP IP, they said only one application, because the application is doing all the tasks. Okay. But if you want to understand the backend, this will be the good approach. You will understand each and every task. Here, if I define all the tasks in one set of only one layer, you will get confused whether application layer is doing the application layer protocols, means defining the application layer protocols, or doing the presentation task or the session tasks. Okay. So we will understand this. Then all you have to understand, okay, these 3 layer tasks done by one single application, that is your new model. That's it. The rest of the everything, transport is transport, network is network, data link is data link, and physical is physical. Everything rest of the things are same. This is clear? Okay. So in case of OSI model, we have 7 layers. Okay. Application, presentation, session, transport, network, data link, and physical. Okay. So the numbering of layers from bottom to up. Layer 1 is physical, 2 data link, 3 network, 4 transport, 5 session, 6 presentation, and 7 application. Okay. Then Software layers, why? Because all the tasks are done by one single application software. Hardware layers, because physical hardware devices are used here. Transport layer, heart of OSI, why? Because end-to-end communication is happening here, and it is the connecting layer between the software layers and hardware layers. Okay. Then after, two most important protocols of communication, TCP and UDP, are used here at this layer. So we'll discuss each and every layer in detail. Okay. Now we'll understand how the data is flowing from the sender to receiver. So let's say this is the sender, this side we have the sender, and the other side we are having the receiver. So if we discuss about the sender will type in some message. Let's say you want to type a message, hi to your friend. Where you will type? In some application, correct? Means you will be delivering the data to the application layer. Okay. Then the data will go through all these layers till the presentation layer. Physical layer. Okay. Means let's say in my laptop, if I'm typing something, so the data will leave from where? From the Ethernet port. The data is going to leave my system from the Ethernet port and through the cable. So cable is what? Physical layer. So means my data is traveling from application layer to physical layer. And before going into my friend's system, it will be connecting through the cable only. Means there it will start from cable and he will receive the final output in the application. This is correct. So from here, we come to a conclusion that on the sender side, your data travels like this. From layer 7 to layer 1. From application to physical. From application to physical. What about the receiver side? In the reverse process, right? From layer 1 to layer 7. Or from physical to application. Is that clear? This is clear how the data flows on the sender side and the receiver side. On the sender side, application to physical. On the receiver side, physical to application. Okay. Now, one by one, we'll understand all these layers. That what is the task of all these layers. First layer is the application layer. Now your application layer, what is the layer number? 7. Correct? Okay. Your application layer is also known as user interface layer. Why? Because it is providing you the interface so that you can start the communication. If you do not have WhatsApp, can you send a message in WhatsApp? No. If you do not have email application, can you send an email? No. If you do not have a browser in your Windows, can you access the internet? No. Means these are providing what? Interface. So your application layer is also known as user interface layer. Now here we are discussing about the application, software applications. Okay. So can we say that your software applications itself are application layer? Can we say that your browser, your Gmail application, your WhatsApp application, these are application layer? Yes or no? Yes. Okay. What is this application layer? Defined in the OSI model? What is the OSI model? No, reference model, but what is it? Only documents. Can it be physical? No. That means your applications cannot be, means any physical entity will not talk about. Why? See, when we are talking about any OSI model or any of the model, we are just talking about the what? Protocols, because in the documents, what is defined? Only the protocols. Means applications are not the application layer. Those applications depend on the application layer protocols. Because anywhere, whether it is session layer, whether it is like, let's say in the layer 3, what is the layer 3? Network layer. We say router is used. So router is just a device, but router is depending on the protocols of the layer 3. That's why we say it is a layer 3 device. Okay. So your software applications, they itself are not the application layer. They will depend on the application layer protocols to initiate the communication or to start the communication. Okay. So some examples of your application layer protocols are like FTP, HTTP, HTTPS, SMTP, Telnet, SSH, and there are more protocols. Okay. Your FTP protocol stands for File Transfer Protocol. Means with the name itself suggests used to transfer the files. So when we are downloading something from the internet, The file is getting transferred from the server to our system. So through what it is happening? Through the FTP it is happening, file transfer protocol. Okay. Then you are browsing the websites. How do you browse the website? Have you seen HTTP and HTTPS? Right? See. I'm saying google.com. Did I give HTTPS? Did I give HTTP? So without HTTP or HTTPS, will my browser be able to access the internet? No, will not be. Now you will say it is accessing. How? Check the URL now. What it is using. Correct? If I use some other website again, let's say this is the website. Did I give anything here? No. Now you are getting this log symbol with a red line. That means, see, right now it is not showing you that whether it is HTTP or HTTPS. Let me copy it. Okay, I'll copy this thing. Because your browsers these days are smart. See, here it is not showing anything. But when I paste it, which protocol it is using? So your browsers are depending on this thing. Same way, your email applications, they depend on the SMT, simple mail transfer protocol. Okay. Now these things, these work in the backend. Okay, we do not see. Let's say emails, you do not see, right? That which protocol it is using. But if you want to see, you can see. How? Let me open. Let's say any random email you will open. Then just go here, more, and say show original. Now this is the raw message that is going to include all the information. Do you see what it is? SMTP. So they will use the protocols in the backend. You will not see in the front end. Okay, just to show you a clear picture so that it becomes more user friendly. See, if you get an email like this, see, this is the clear email. So if you get an email like this, will you be interested in reading this email? No, you will not be. Okay. See, this is the actual content of the email. So what my browser is doing, just reading all this content and then just providing me this video. So this is how they are making it user friendly. But in the backend, this is the thing that is actually working. Okay. This is clear. Similar way, we have your telnet and SSH protocols. So telnet and SSH protocols, these are the remote access protocols. Okay. And like by Friday, we'll be completing the telnet SSH also. Okay. And in the lab, I'll show you that how you can configure telnet and SSH and you can get access. Okay. Means we'll be going to the lab either Thursday or Friday. Okay. We'll go to the lab and we'll see how to access these routers and devices, how to do the basic configurations in them. All these things we'll understand. And that time I'll show you that we can access using telnet. Okay. So this is clear. Now you must have to remember few of the protocols. Okay. You have to remember some of the protocols with their port numbers. Okay. So this is your task. You have to remember or check out about the common protocols with the port numbers. Okay, because these things they are asked in the interviews. Okay, anyone can ask you what FTP protocol, which port number. Okay, then HTTP protocol. So you will say HTTP works on port number 80, HTTPS works on port number 443. Okay, like this, few of the protocols like FTP. Okay, most common protocols like FTP, DHCP, DNS, HTTP, HTTPS. These are the protocols like Telnet, SH, SMTP. So there are like around 10 to 15 common protocols that are like commonly asked in the interviews. So those things you have to remember, okay, with the port numbers. This is clear about the application layer. Next is the presentation layer. Okay. Now, whenever we type the message, how we are going to type in the English? Does your computer understand English? Does your wires understand English? No. What they understand? Zeros and ones, binary. So means someone has to convert the data into binary so that your system can understand. That task will be done by your presentation layer. Your presentation layer defines the format of the data. Means from user readable form to system readable form, and when someone is receiving the data, from the system readable form to user readable form. Okay, see what happens whenever you download some music, you get the MP3 file. Whenever you download a video, you get the MP4 file. Whenever you download an Excel file, you get Excel file only. So who is see when the data is traveling inside the network, inside the wires, that time it is not traveling in a format. That time it is only traveling in binary bits. Means depending, let's say if you have Ethernet cables, then it will be traveling in the form of electric signal. If you have the fiber cables, it will travel in the form of light signals. If you have the Wi-Fi, if you are using the Wi-Fi, in that case, it will travel in the form of radio beams, right? Not a fixed format. But still, every time we receive the data or send the data, we get in the correct format. So who is doing or who is defining the correct format of the data? Your presentation layer. Okay. So we have the task for presentation layer. First is the translation from human readable form to binary, binary to human readable form. Second is the compression. So what is compression? Whenever you are trying to send the data, okay, then for increasing the speed of communication, the data will be compressed. Now, what do you mean by compressing? Reducing the size of data. Okay, like we have a big file, then we will add it into the zip file like archive files, and the size will get reduced. Okay, so like this, the data will be compressed. Let's say you have 5 MB of file, and that will be reduced to 2 MB of file. Okay, so this is going to increase the speed of communication. How? The question is how? How it is going to increase?
So it's small that takes less time.
Less time? Correct. See how the things will happen. For example, let's say this is the sender, and this side we have the receiver. And between them, we have a connection 100 Mbps. Correct? Now, how much data can be sent from source to destination or sender to receiver in 1 second? 100 MB? Okay. Means if this side we have a 100 MB packet, so that will be sent in 1 second. Correct? Now, what we are doing, this 100 MB packet, we are compressing it to 20 MB. Means the size is 20 MB, but still inside data is what? 100 MB only. Correct? Now, this time ultimate data going how much? 20 MB. So how many 20 MB packets I can send here? 5. And when this 5 packets come this side and I decompress, what will be the total size? 5 packets. 500 times? I mean, sorry, 500 MB. So earlier in 1 second, I was getting 100 MB data. Now in 1 second, I'm getting what? 500 MB data. That means, can I say my speed increased? Can I say my efficiency increased? Means earlier in 1 second, I was able to carry 100 MB. Now I'm able to carry 500 MB. So that means it is going to increase the speed and efficiency of communication. Is that clear? Next, we have encryption and decryption. Okay, your WhatsApp says end-to-end encrypted. So how do these things work? So if you are communicating over an encrypted communication, okay, then where your data will get encrypted? In the presentation layer. Okay, and on the receiver side, where the data will be decrypted? Presentation layer itself. Okay, so your presentation layer is responsible for encryption and decryption. Okay, so what will happen? The sender will apply the encryption, the receiver will decrypt the data or remove the encryption. But what is encryption? What is encryption?
Changing information to binary.
Yes.
Changing information into binary.
Changing information to binary? No.
And you can-
Changing some readable information into scrambled text means unreadable form. Converting the data into unreadable form. See, binary anyone can convert, but if you convert it into unreadable form, okay, means that is some random text, then what will happen? Then you cannot decrypt. Means not easily you can understand. And for this, we have lots of different encryption protocols. Okay, those things we'll also discuss. Okay, this is clear. Encryption and decryption. So these tasks are also done by your presentation here. Is that clear? Clear about presentation here? Any doubt? Guys, online people, any doubt? Clear. Okay.
Yes.
The next we have session layer. Now, what is the session first of all?
Time spent.
Means kind of duration. So what do we call a session here? Means the time, the point from which you start the communication till the communication ends. The duration between the start of communication and end of duration communication is known as session. Same like our class. We start the class at around 8, we end at around 10. So that this 2 hour duration is known as a session. Okay. Now what will happen? What is your session layer responsibility? First of all, to initiate or start a session between the sender and receiver so that they can start the communication. Once the session has started, the session layer is also responsible to maintain the session. Why? When the data transfer is happening, the session should be maintained. If the session terminates, the data transfer will terminate. Okay. So your session layer is responsible for establishing the session, then maintaining the session as long as the data transfer is going on. Okay. And as soon as the data transfer is complete, it is also responsible for terminating the session. Okay. Now understand. Let's say you are trying to download a file. So before downloading a file, you will get connected to the server. That is start of session. Now, as long as the file is downloading, your internet speed will be good. You will be getting the speed, right? And as soon as the download will complete, what will happen? Your internet speed will instantly reduce. That means the session will be terminated. You will get disconnected from the server because you have already received the file. Now tell me what will happen if that speed does not reduce. If that speed does not reduce, means your system, your phone, your device will continuously be sending the data at the same speed. But your file is already downloaded. You are just not disconnected to the server. From the server, you are not disconnected. Your file is already downloaded. That means your data will be wastage. Your data will be wasted. So to prevent the wastage of resources, your session layer is also responsible for terminating the session. This is one example. Second example, let's say you access your internet banking website. First of all, you will be authenticated. How? You have to provide your username and password. Then only your bank server will be able to verify whether you are the correct user or not. Okay, let's say you have authenticated. You have logged in. Then your session will start. Started. Then what will happen? For as long as you are browsing that website, will you get the message like your session logged out? Session expired? Do you get? If you are visiting the website, if you are doing the website, working on the website, you will not get this message. But if you have opened the website and if you are visiting some different tab or doing some different task, then what will happen? Session will expire. Means these things are controlled by your session list. Your session is established, maintained, and terminated by your session layer. Okay. Authorization is also done. Authentication means verification of user. Authorization means what? Authorization means defining level of access. See, when you log into your internet banking, do you have complete control over your account that you can go and change anything in your account? No. You have a certain level of access. And what defines that certain level of access? again your session layer. Okay, that how much access you have, that access will also be defined by your session layer. That is clear. Okay. Next is the heart of OSI, transport layer. Okay, now transport layer is responsible for end-to-end communication. Okay, now one more point, your transport layer provides service to application layer protocols. Okay, what does it mean? I said that two important protocols of communication are used here, TCP and UDP, correct? And just now we discussed that we have a protocol HTTP, we have a protocol HTTPS, correct? If you check the port numbers for these protocols, this will be port number 80 and the service they will be using is TCP. If HTTP is port number 443, service TCP. If you are talking about DNS, we'll be using port number 53 and TCP and UDP both. Okay, so like this, it will be providing, because see, these protocols will not be working until or unless the transport layer is providing the service. So your transport layer, first of all, it is responsible for end-to-end communication. Second thing, it is providing service to application layer protocols. Provide service to application layer protocols. Okay, then some of the tasks for transport layer are segmentation, flow control, error control. Means, let's say if you are getting corrupted data packets, okay, and you see that whenever you are downloading a file, your internet speed is not constant. Sometimes it will go 4 Mbps, sometimes it will come in the KB, sometimes it will be 2 Mbps, sometimes it will be 10 Mbps, depending on your connection speed. But it doesn't remain constant. Why? Because there is something called as flow control. Okay, so we'll discuss about each and every task that, okay, segment, what is segmentation, what is flow control, what is error control. Okay, then connection and connectionless transmission, this is nothing but TCP and UDP only. Okay, so in the next session we will completely discuss about TCP and UDP. This is clear. So one by one we'll see what is segmentation. So what is a segment? Part of data. Okay, when we're discussing data, that is part of data is a segment. So up till your session layer, okay, we have application layer, we have presentation layer, we have session layer. Up till your session layer, the data will be known as data only. Whatever we provide, that will be known as data only. Now this data, when it comes to the transport layer, it is broken down into segments. Okay, because you see, if you are downloading a 500 MB file, that 500 MB will not come all at once. It will come into pieces. Those pieces are done by your transport layer. Okay. For example, let's consider this is the message you want to send. Now, when this message comes at the transport layer, it will be divided into 3 segments. Okay, this is not the like hard coded thing. This is just an example that, okay, 3 words, so 3 segments. Okay, now see, this is the message now sent to the receiver. Now when the receiver is receiving, so let's say due to some congestion in the network or due to any reason, the receiver received the I message first, then it received the exclamation, then it received the H. Now is it the correct information? No, it's not the correct information. Means it has to be reassembled, reordered, and put into the correct sequence. So for this purpose, your transport layer is going to attach something called as sequence number. It will attach that, okay, this is the first segment, this is the second segment, this is the third segment. Now, when the receiver will receive, it will have the information that, okay, this is the first segment, this is the second segment, this is the third segment. Now, first of all, before delivering the data to the application, it is going to reassemble it. Okay, and it is going to say first segment, second segment, and third segment. And now you have the correct data. Okay. But again, there is a problem. What is the problem? Let's say you have sent a message in the WhatsApp. Your friend will get the message in the WhatsApp, Gmail, browser, where? WhatsApp. If you send an email, where he will receive? Email. If you are searching something on the browser, let's say if I go to the Firefox and if I search what is my IP address, will I receive in my Zoom? No. Will I receive in present PowerPoint? No. Why? Because the data is getting delivered to the correct application. And how the data is getting delivered to the correct application? Based on the port numbers. Now remember, HTTP uses port number 80. Means any traffic going to port number 80 is for HTTP. Any traffic going to HTTPS is for, sorry, 443 is for HTTP. So your port number defines that the data is getting delivered to the correct application. Sequence number for correct reassembly to reorder the data into the correct sequence, and port number to deliver the data to the correct application. Now, both of these information your transport layer is going to attach with the segments. With each and every segment, these informations will be attached. And not just these, even more information will be there. When we'll discuss about TCP and UDP, we'll see about TCP header and UDP header. There you'll see that not just these two things, but more things are attached. But as of now, sequence number and port numbers. Is it correct? Now, about port numbers, these port numbers are nothing physical. Okay, these are not like the ports. These are logical port numbers. Okay, so total 65,536 port numbers are there. And the range will always start from 0 till 65,535. This is the total range of port numbers, whether it is TCP, whether it is UDP. Okay. Out of these port numbers 0 to 1023, they are reserved. Why? For the protocols like HTTP, HTTPS, DNS, we say fixed number of ports. So these ports are fixed with the protocols. Then from 1024 till 65,535, these are known as well-known ports. And these ports, these are known as dynamic ports. These are known as dynamic ports. Means these can be used randomly. Because see, whenever sequence number and port number information is attached. So whenever system is attaching the port number, always a source port and a destination port is attached. So let's say if I'm visiting a website that is HTTP. So my destination is HTTP, means port number 80. But I need a source port also. So your computer, your system is randomly going to assign a port number between this range. So that's why these are known as dynamic ports, so that your system can randomly choose a port number. Okay. This is clear about the segments. Okay. Next is flow control. So what is the flow control? Flow control means controlling the flow of communication, means controlling the speed of communication, either decreasing the speed, either increasing the speed. Okay. So for example, let's consider this is one computer supporting the speed of 100 Mbps, and this is one phone supporting the speed of 10 Mbps. This is sender and this one is receiver. Sender can send at a speed of 100 Mbps and receiver can receive at a speed of. Now what will happen if your sender starts sending at full speed? Will your receiver be able to receive? No. In 1 second, it will send 100 MB of data. Let's say 100 MB of data. It will receive only 10. In the next second, again, it will send 100 MB. Again, in the next second, it will receive 10. Again, in the next second, 100 and will receive 10. So means the data will get collected. And there will be a time when the data will start dropping. Not a good thing. So what your receiver is going to do? The receiving side transport layer is going to communicate with the sending side transport layer, and it is going to say, the speed is so fast for me, please reduce the speed of communication. So the sender will adjust the speed according to the receiver. Reduce the speed of communication. Similar way, if the sender is sending at very low speed, let's say sending at only 5 Mbps, then again the receiver will say that this is too slow. I can support more speed. So send at a faster speed. So the sender is going to increase the speed of communication. Okay. So every time when you're downloading something, your phone, your device is continuously communicating with the sender and telling that, okay, this right now I can I can receive at this speed. Right now I can receive at this speed. And that's why your internet speed keeps on fluctuating, not a stable speed you get. Okay. Flow control clear? Next, we have error control. So what is error control? See, let's say again, this is your high message, HI exclamation, and having the sequence number 1, 2, 3. So data 1, 2, 3. What will happen? Let's say the receiver has received the first segment, the second was lost in the communication, and the third was received. Now receiver, when it will try to assemble the data, it will check, I have received the first unit, I have received the third unit. Something is missing. So it will say, I have not received the second unit. Then your sender is going to retransmit the second unit. And then it will complete the data and the data receiving will be completed. Okay. Second, what will happen? Let's say, for example, again, the high message is there. Okay. So what your receiver will do, it will receive, let's say, all 3 packets, but it will check whether the data is correct or not. Whether the data is correct or not. How it is going to check? With the transport layer, we will have something called as checksum. In the transport layer, when they are attaching source port, destination port, sequence number, along with that, they will also attach a checksum. Now, what is a checksum? Let's say this is your segment, H segment. Okay. And they have attached the sequence number, they have attached the port number, all these things. Okay. Along with the sequence number and port number, they will also attach something called as checksum. Now, what is this checksum value? Whatever is your data, on that data, they will run some algorithm. Okay, they will do some maths and they will calculate a value. Let's say value is 1, 2, 3. Now this 1, 2, 3 value will be stored in the checksum part. Then this segment will be sent to the receiver. Receiver will receive the same segment, H, sequence number, port number, and the checksum. Now your receiver will also run the same algorithm. Receiver will also run the same algorithm and it will calculate the value. Let's say value again is what? 1, 2, 3. Then it will verify whether these values are same or not. If these values are same, that means the data has not been modified in the transit. When the data is traveling from source to destination, the data has not been modified. But if this value changes, let's say 1, 2, 4, now it will verify value changed. That means this data has been modified. So it is going to drop this packet. It will come to know that, okay, someone has changed the data and it will drop the packet. Okay. So it will drop the corrupted packet and then again it will ask that number 3, I want again. And it is going to retransmit the number 3. So this is how they are going to control the error detection and error control. Okay. Now this checksum, it is nothing but a hash value. It is nothing but a hash value. What is a hash value? See, there is 2 things. One is the encryption and second is the hashing. Okay. Encryption is used for confidentiality, so that no one can read your data, because changing the data into scrambled text. And for encryption, we have something called as decryption. Correct? Means if you encrypt the data, you can decrypt the data. Okay. Then what is hashing? Hashing is for the integrity of data, to check whether the data has been modified or not. Here we cannot see whether the data has been modified or not. Okay. Because anybody can, let's say my message is high. And if a hacker is there on the network, he might sniff the data. See, let's say if I'm using encryption algorithm E1, okay, just an example. So what he will do, he will decrypt this and then he might change this data to, let's say, hacked. And then he is going to encrypt the data with E1 and then send it to me. My system knows how to decrypt E1 and my system will decrypt the data. So I will not know whether this is the actual data or something else was actual data. So for checking the integrity, we have the hashing. Hashing is irreversible. Your encryption can be decrypted, but your hashing cannot be reversed. Okay. And even if a single bit, even if a small part of the hash or actual data is changed, let's say this is the message, and with this the hash value came out 123. Now, if someone just make a small change, let's say made I capital, still to us it looks the same high only, but the hash will change. Okay, let me show you one small example. With the same message only, I'll show you. You can say hash generator. Okay, there is lots of websites that will generate the hashes for you. Let's go with the MD5 algorithm. Okay, let's say the same message I'll type hi. Okay, and for this message I will generate a hash value. This has been generated. Now see, I type the message hi, and according to this, my hash value is this. Okay. Now see, I'll make a small change. What I'll do, I'll make I capital. Generate. Copy. And for this value, my hash value is, do you see? So if someone modified the data in the transit, this is the value that the receiver is going to receive in the checksum part. And this is the value that it will calculate by itself. Now it will verify, are these the same values? No, these are not the same values. Means this data has been modified. And if the value is same, if the data is actually same, let's say again, I will make it small I, and I will generate the hash value. I'll copy it again. If my data is legit, verify, same. Okay, so this is how the receiver will come to know that whether the data has been modified or not. And what happens in case of hashing, even if a single bit is changed, each and every bit of this hash value has a 50% probability to change. Means small change, entire hash will change. You see, I just made I capital and the entire hash value has been changed. Okay, so like this, these values will change. Is that clear? This is how the receiver will come to know that, okay, the data has been changed or not. If the data is same, obviously both sides, the value will be same. But small change, the data will change. And it will consider this is a corrupted packet, drop it. Okay. Then connection and connectionless transmission. So we have two protocols. One is the TCP and one is the UDP. Your TCP is known as connection-oriented protocol. Connection-oriented means it is going to check for the connection, whether between the sender and receiver, do we have a proper connection? Is the connection maintained? Okay, so it is going to maintain the connection, check for connection. So this is connection-oriented. UDP, connectionless, does not check for connection. See, this is one example given here, UDP and TCP. Self-understandable. If you try to fly, you have a chance of accident. And if you walk, you don't have a chance of accident. Okay. Then your TCP, where it is used? Almost everywhere. So does it mean UDP is not used? No. In our daily life, we use UDP also. See, whatever live stream is going on, let's say you're watching live news channels, TV channels, or right now, most of you will be watching IPL, right? So all these things are UDP based. Even our Zoom session is UDP based. Why? Because this is going on live. And what is the problem with the UDP? That UDP does not maintain connection. If some part of the live stream is lost, that is lost. You're not never going to get it back. Okay, that is the UDP. TCP, let's say you're downloading a file from the internet, not completely downloaded. You can pause and start anytime. Okay, if you are watching a movie online, okay, let's say from some online platform like Netflix or something, what will happen? If you missed some part of the movie, you can just always go back and watch it again. So that is a TCP based. Okay, so in case of TCP, there is reliability. In case of UDP, there is no reliability. Okay, and let me show you about UDP or our Zoom session. So we have a packet analyzing tool, that is Wireshark. Okay. So with this, you can analyze all the packets, what all the packets are going on. So you'll see that right now I'm connected over Wi-Fi. So if I want to check what all the packets are transmitting through my Wi-Fi, you see which protocol. This is UDP protocol. And why so many packets are traveling? Because these are Zoom. Okay. This is clear. Next, we have network layer. Now, network layer makes use of your logical addressing. Logical address is IP address. Okay. IP address is a layer 3 information. Okay. Then also responsible for routing. Routing means forwarding the data packets from one network to another network, and also responsible for determining the path, that which path your data is going to take to reach from source to destination. Okay, in our introduction to the router and that part, we already discussed this thing, right? That if you want to go from receiver to sender, sender to receiver, so which path? We have multiple possibilities, but we are always going to check the shortest one. Okay, so we will use some parameters. So for determining the best path, we have different protocols here, like OSPF, BGP, ISIS, we have RIP, we have IGRP, we have EIGRP. Okay, like this, multiple protocols are there. Okay, so with the help of these protocols, all these protocols have their different set of rules, how they are going to decide which path is the best. Okay, so that part will come across when we're discussing about the routing protocols. But just focus that, okay, from source to destination, from Delhi to Bangalore, from Bangalore to Delhi, we have multiple possibilities to go from, right? But we will always go with the shortest one, whatever is the best according to us. Okay. So these are the tasks of your network layer, and here we use a special type of device that is known as router. Okay. Now here I'll give you one more task. You have to find out the difference between routing protocol and routed protocol. Like what is routed protocol and what is routing protocol. Okay, these things they are again asked in the interviews. Clear? So network layer is clear? Because about router and logical addresses, these things we have been already discussing. Okay. Next is the data link layer. Now data link layer is responsible same like router task. See, your router communicates between two different networks, forwards data packet from one network to another network. Same way, your switch forwards data packet from one PC to another PC, one node to another. Means kind of your switch is also just forwarding the frames only. Okay, here we call the, in the case of network layer, we call it packet. In the case of data link layer, we call it as a frame. Okay, see, in case of transport layer, it will be known as segment. Okay, segment in case of TCP and datagram in case of UDP. Okay, then in case of network layer, it will be known as packet. In case of data link layer, it will be known as frame. So the process of creating frames from the packets, that is known as framing. Okay, then at physical layer, it will be converted into binary. Okay, I mean not binary, but you can say it will be converted into the signals, whatever according to your media. Okay, now see, Framing is clear, converting the packets into frames. Error detection. Now, how your error is detected here? So see, this is your segment at the transport layer, H. With this information, sequence number, port number attached along with the checksum. Then this is known as here segment. Next, it will come to the network layer. At the network layer, you have this message, sequence number, port number. Now your network layer is making use of IP addresses. So it will define what is the source IP, what is the destination IP, means from where this packet is coming and where this packet is going, source and destination. So this entity will be known as packet. Now it will come at the data link layer. So again, you have your segment, then again sequence number, port number. Then you have source IP, destination IP. And in case of data link layer, what we make use of? MAC address. So it will have source MAC, destination MAC. But along with the source MAC and destination MAC, at the back of the packet, it is also going to attach something called as FCS. FCS is what? Frame check sequence. FCS is frame check sequence. Again, this is nothing but a hash value only. So you see, when the data is transmitting at two levels, it will be checked for corruption, whether the data is corrupted or not. So this is again nothing but a hash value that will, like your data link layer, it will run some algorithm, calculate a value, store in the FCS field. When the receiver will receive, first of all, receiver is going to check whether it is for the receiver or not. Once it confirms that, okay, it is for me only, then next it will check the FCS, whether it is corrupted or not. Okay, like that. So this entire entity will be known as a frame. And your data link layer switch is used. So how you switch forwards the packet to the correct destination according to MAC address. It will check the destination MAC address. The router will check the destination IP address. Okay. So according to this, they are going to forward the frames. So see, whatever information is attached in front of the packets, that is known as header. Whenever an information is attached in front of the packet, that is header. And if something is attached in the back of the packet, in the end of the packet, that is known as trailer. Header and trailer. So only in the data link layer, header and trailer both are attached. Remaining layers, only header will be attached. Is that clear? Data link layer, clear? Then we have the physical layer. So physical layer is going to convert the bits into the signals according to the media. If you have a wired media, it will be converted into electrical signal. If you have a fiber, it will be converted into electrical. If you have a wireless media, it will be converted into radio waves. Okay. So it will take up the bits, convert it into signals, and whatever is your media, according to that, it will load it into the media. Now receiver will receive the message and then will convert it back into signals and the signals back into bits. Okay. And from the bits, the reverse process will start. Is that clear? Okay. Now, the entire process in one single go. Okay. You gave the message hi to the application layer. Here it is known as data. Okay. Use the protocol of the application layer, convert it into binary. If encryption was required, the encryption was done. Okay. Then the session was established. Then it was given to the transport layer. At the transport layer, this was converted into segment and your source port, sequence number and port number were attached. This entity was known as segment. The segment was delivered to the network layer. At the network layer with the segment, whatever segment you have, source IP and destination IP information was attached. Then this entity is known as packet. This packet was given to the data link layer. At the data link layer, source MAC, destination MAC was attached as a header. In the trailer, FCS was attached. And this entity will be known as frame. Okay. Then this frame was given to the physical layer. At the physical layer, it was converted into signals and loaded onto the medium. From the media, it received on the receiver side. Receiver side physical layer converted it back into the bits. Okay, let me change the color. It was converted back into the bits. Now, the bits were delivered to the data link layer by converting a frame. Now it will check whether the destination is correct or not. Is it for me or not? Because whenever you receive a letter or a courier, you will always check whether it is for you or not. Similarly, it will check whether you are the correct destination or not. Is it correct? We'll check for the FCS, whether it is corrupted or not. Not corrupted, remove all the information that was attached by the sender and then forward the packet information to the network layer. Network layer will check, am I the correct IP? Is it for me? Yes, it is for me. Okay, remove this information, then send it to the transport layers. At transport layer, first of all, the data will get assembled according to the sequence number. Then it will check the port number, and according to port number, it will be delivered to the correct application. And in the application, the receiver will receive the message. So this is how the entire process is happening. Is that clear? So any doubt in the OSI model? Yes or no? No? Now what is the difference? Difference is whatever task we have understood in the application presentation session, all those tasks here we will study in the one single application layer. So you just combine these three layers and your TCP/IP updated model is done. So any difference, anything, any doubt? Yes or no? No? All right. So now, are you guys ready for the test? Ready?
Yes, sir.
Okay. So in this, you are not having a doubt. So I can stop the recording, right? Okay.